The Great Sphinx of Giza has been telling us its true age for thousands of years. We just have to understand the language of stone. By the end of this, you will see this iconic monument not as a static statue, but as a geological clock with a startling message. The evidence is carved into its weathered body, suggesting it witnessed a green Sahara and rains that ended before the pyramids were even conceived. What does it mean if the guardian of the plateau is older than the civilization it supposedly represents? What story does a rock remember when it has seen epochs come and go? Are we prepared to listen to a history written not in hieroglyphs, but in erosion? Our story begins with a date most of us learned in school, around 2,500 years before the Common Era. This places the Sphinx firmly in the reign of the Pharaoh Khafre, the builder of the second Great Pyramid at Giza. According to this narrative, the Sphinx was carved as a majestic guardian, a lion with the pharaoh's own face, watching eternally over his tomb complex. The evidence for this seems solid at first glance. The Sphinx sits within Khafre's pyramid complex. Its head bears a resemblance to statues of that king, and the archaeology of the surrounding temples aligns with the Fourth Dynasty. It is a tidy, logical package, the kind of history that fits neatly into a textbook chapter. For over a century, this has been the foundation of our understanding, a story built on context, style, and educated deduction. But what if this foundation is not as solid as bedrock, but more like the shifting sands that surround it? The case for Khafre is compelling, yet it remains circumstantial. It is built on proximity and plausible artistic attribution, much like concluding a painting's artist based solely on where it was found in a gallery. There is no inscription, no contemporary record that definitively says Khafre built this. This established timeline, comfortable and widely accepted, creates a specific expectation. A monument carved in the middle of the 3rd millennium BC should show a certain kind of wear, consistent with the dry, windy desert climate it has endured for 4,500 years. Yet when you stand before the Sphinx and look past its missing nose, you see something else entirely. The body of the beast tells a story of deep, undulating wounds, of vertical channels cut into its limestone core that speak not of wind and sand, but of something far more powerful. This profound, distinctive weathering is the first crack in the standard narrative, a silent geological testimony that invites us to look closer, to question the comfortable story, and listen to what the stone itself has been trying to say all along. The most telling clues are not found in any ancient text, but carved directly into the limestone itself. Look at the body of the Sphinx, at the walls of the pit from which it was hewn. You see deep, vertical channels like giant gutters and undulating, scalloped hollows that ripple across the stone. To a geologist, these are not random scars. They are a signature. This is the unmistakable signature of water, and not just a little water, but a lot of it falling over a very long time. Wind and sand, the forces we associate with the desert, create a very different kind of wear. They sandblast surfaces, polishing and pitting them in a horizontal fashion, like a relentless, gritty breeze smoothing a piece of wood. What we see on the Sphinx is entirely different. It looks less like something sanded down and more like something that has been deeply, persistently rained upon. Picture a limestone cliff face in a temperate climate, where water runs down its surface for centuries, dissolving the softer layers and carving those characteristic vertical runnels. That is the pattern we see here, right in the heart of the Egyptian desert. This observation leads to a profound and unsettling question. When was the last time the Giza Plateau experienced rainfall heavy enough and consistent enough to carve stone in this way? We are not talking about the occasional rare storm. We are talking about a climate regime. Geological and paleoclimatic data tells us that region of Egypt transitioned from a relatively wet period to the hyper-arid desert we know today around the end of the last ice age. The greening of the Sahara, a time of lakes and savannas, gave way to increasing dryness. By the time of the Old Kingdom and Pharaoh Khafre, roughly 4,500 years ago, the climate was already largely arid, much like it is now. The conditions necessary to create the deep, flowing water erosion on the Sphinx had likely vanished millennia earlier. So if the monument was carved in 2500 BCE, it should primarily show the effects of wind and sand. Yet its most dramatic weathering tells a story of rain, a climate memory locked in stone that points to a much earlier chapter. This single geological clue acts like a key, turning in a lock we never knew was there, and the door it opens leads not into a known pharaoh's tomb, but into a far deeper, mist-shrouded past. That story of water is written most clearly in a single, powerful comparison. Stand before the Sphinx and your eye is immediately drawn to a stark visual contrast. The massive, ancient core body of the statue, carved from the living limestone of the plateau, shows soft, undulating, deeply rounded hollows. It looks almost melted. But then look at the stone blocks that patch its sides and pores, repairs made by the ancient Egyptians themselves, and later by more modern conservators. These blocks are sharply cut with crisp 90-degree angles. Their surfaces are pitted and worn, yes, but in a completely different way. They show the abrasive, sand-blasted wear of the desert we know today. This is not a subtle difference. It is a glaring side-by-side timeline. The original body of the Sphinx has endured an environmental punishment that the newer stones, some of them thousands of years old themselves, have simply never experienced. They were placed into a world that had already dried up. The original rock remembers a different world altogether. The most telling evidence of this is on the western wall of the enclosure, the deep trench that surrounds the monument. Here, the weathering follows the natural horizontal layers or bedding planes of the limestone. Water does not just run straight down. It seeps into the cracks between these layers, percolating horizontally, dissolving and undermining the stone from within over centuries. This creates those characteristic overhangs and deep undercuts. It is a process that requires consistent, heavy rainfall to drive water deep into the rock, season after season, for a very, very long time. The restoration blocks sitting in the same desert for millennia show no such damage. They only know wind and sand, so we are left with a monument that displays two distinct geological histories. One is a biography written in deep water erosion, a climate memoir of a green Sahara. The other is the later chapter of arid desert winds. This forces a profound question. If the Sphinx was carved around 2500 BCE, why does its core body bear the scars of a climate that vanished thousands of years before that date? The stone itself seems to be a relic from an earlier epoch, silently waiting for us to read its true age in the language of erosion. This weathering pattern is not just a clue, it is a clock. To read its time, we must understand the climate that wounded it. The key lies in a field called Paleoclimatology, the study of ancient weather. Scientists do not dig up old weather reports, of course. They read the stories told by things like fossilized pollen grains, the layered mud at the bottom of long-vanished lakes, and deep cores drilled from ocean floors and desert plains. These natural archives reveal a stunning truth about North Africa. The Sahara was not always a desert. For thousands of years, it was a green and habitable land, a period scientists call the Neolithic subpluvial. This was an era of regular rainfall, of grasslands and lakes where animals like giraffes and hippos thrived, a world utterly alien to the dunes of today. The data tells us this green phase began to fade, giving way to increasing aridity, with the last truly significant rains tailing off somewhere between 5,000 and 3,000 years before the Common Era. The transition to the hyper-dry desert we know was essentially complete by the time the pyramids were being planned. This timeline is our calibration point. For the Sphinx to bear the deep, flowing water scars we see, its limestone core needed to be fully exposed, sitting in that open trench during that long, rainy epoch. The erosion had to begin when the rains were still a powerful landscape-shaping force. Think of it like this: if you leave a wooden bench outside, its weathering tells a story. If it shows only slight fading, it has only known gentle sun. But if it is warped, cracked, and deeply grooved by rain, it tells of seasons of storms. The Sphinx is that deeply grooved bench. The most compelling geological assessments suggest this water weathering likely began its work around 7,000 years before the Common Era, or even earlier. That is a staggering thought. For the erosion to have started then, the monument itself must have already been standing, its form carved from the bedrock, ready to face the downpours. That pushes its creation back not just centuries but millennia before the reign of Khafre. We are no longer talking about a pre-dynastic Egypt, but a potentially pre-agricultural one, a time of hunter-gatherers and early pastoralists. The climatic data transforms the Sphinx from a static statue into a geological chronometer. Its weathered flanks are not just damage, they are a record of the last great rains, a stone diary entry dated to a forgotten green world that the civilization of the pharaohs could only have known as legend. This geological clock, however, is not the only timepiece in the room. A compelling counter-argument exists, one that seeks to keep the hands of history set to the traditional date. Not all experts look at the same stone and see the same story. A number of geologists and archaeologists, including voices like Dr. James Harrell, propose a different explanation for the Sphinx's dramatic appearance. Their view is that the weathering can be fully explained by the forces we know have been at work for the last 4,500 years, just operating in a more complex way than we might assume. This wind and sand hypothesis is a crucial reminder that in science, every extraordinary claim must face rigorous scrutiny. Proponents of this view point to the very nature of the limestone at Giza. It is not a uniform block of stone but a layered cake of different densities. Some layers are harder, some are softer, and some are packed with clay. When you expose this variable rock to the desert environment, they argue, it weathers in complex, dramatic patterns that can mimic water erosion. The primary culprits in this model are wind-driven sand, which acts as a natural sandblaster, and a process called salt exfoliation. In the desert, moisture from the air or even from morning dew can seep into the porous stone. That moisture often carries dissolved salts. When the sun comes out and the water evaporates, those salt crystals are left behind inside the tiny pores of the rock. As the crystals grow, they exert immense pressure from within, literally forcing thin flakes of the stone's surface to pop off. Over centuries, this repeated flaking can create rounded, undulating surfaces. Add to this the undeniable fact that Egypt does experience occasional, heavy rainstorms, even today, and critics argue that the combination of these factors over millennia is sufficient to explain the Sphinx's condition without invoking a lost rainy epoch. They maintain that the traditional timeline holds and that the monument's erosion, while severe, is not an anomaly. It is a testament to the destructive power of the very desert it has guarded for all of recorded Egyptian history. This perspective anchors the Sphinx firmly within the world of the pharaohs. It challenges us to look closer, to ask if we are seeing what we want to see in the stone, or if the stone is truly telling us a secret. To move past this debate, we cannot just look at the shape of the erosion. We must listen to the rock's own chemistry, to the whispers of minerals that remember where they have been. The debate between wind and water hinges on what we can see with the naked eye. but the stone holds memories too small for us to witness directly. To settle the argument, we must listen to the rock's own internal story, told not in grand shapes but in the microscopic world of its crystals. This is the realm of petrographic analysis, a scientific process that reads a stone's biography at a cellular level. Imagine taking a sliver of the Sphinx's limestone, thin enough to let light shine through, and placing it under a powerful microscope. You are no longer looking at a weathered statue, but at a hidden landscape of mineral grains, tiny fossils, and the microscopic scars of environmental history. It is like reading the diary of the rock, page by crystalline page, searching for entries about ancient storms. What researchers look for here are specific patterns of decay. When limestone is weathered by wind and sand, the damage is primarily physical. Grains are knocked loose, surfaces are abraded. But when water is the agent, especially over vast stretches of time, the chemistry of the rock itself begins to change. The water, slightly acidic from absorbing carbon dioxide from the atmosphere, slowly dissolves the primary mineral in limestone, which is calcite. This dissolved calcite doesn't just vanish. As water evaporates or conditions change, it can reprecipitate elsewhere within the rock's pores, forming new layers of crystal that bind grains together or fill cracks in a different pattern. Proponents of an older Sphinx point to evidence of this deep, pervasive dissolution and reprecipitation within the core body stone. They argue that the extent and nature of this chemical alteration are signatures of prolonged, intermittent saturation by rainwater. This isn't the work of a few rare downpours over 4,000 years, they suggest, but of a climate where the rock was regularly soaked, dried, and soaked again for a much longer period. It is a process that requires both the presence of significant water and the luxury of immense time, conditions that align with the green Sahara epoch, not the arid Old Kingdom. This petrographic evidence aims to move the debate from the realm of observable shapes, which can be interpreted differently, into the domain of quantifiable chemistry. It asks us to consider not just how the stone looks, but what it has become through millennia of interaction with a forgotten world. If the stone's very molecules tell a story of abundant water, then the Sphinx must have been present to hear that story's first chapter. This microscopic testimony seems to whisper of an age measured not in dynasties, but in climatic shifts, pushing the narrative into a past so deep it challenges the foundations of history itself. The story of the Sphinx is not only written on its surface, but also whispered from deep within the earth. To truly understand its age, we must listen to what lies beneath its massive pores. This is where geology moves beyond observation and into the realm of detection, using technology to listen to the echoes of the past. In the 1980s and 90s, teams of researchers conducted a series of seismic refraction surveys around the Sphinx enclosure. The principle is elegant in its simplicity. You create a small vibration at the surface, a sort of controlled tap on the ground, and then carefully measure how the sound waves travel through the different layers of rock below and bounce back to the surface. Different materials and rock in different states of preservation transmit these waves at different speeds. It is like a geological sonogram, creating a rough image of the subsurface world. These surveys revealed fascinating anomalies, hints of possible cavities or tunnels that have fueled speculation for decades. But for the question of age, the most telling data was far more fundamental. The surveys allowed scientists to profile not just the shape of the rock below, but its condition. They could, in effect, measure the depth of the weathering. Think of it this way: if you suspect an old wooden beam in your house has water damage, you do not just look at the surface, you probe it. You check to see if the rot is just a surface stain or if it goes deep into the heart of the wood. The depth of the damage tells you how long the leak has been active and how serious the underlying problem truly is. The seismic surveys aim to do precisely this for the Sphinx enclosure. The critical question was, how far down does the distinctive weathering pattern extend? If the water erosion proposed by some researchers is real, it should not be just a surface feature. The effects of thousands of years of rainwater would have seeped downward, following cracks and bedding planes, altering the rock deep below the floor of the enclosure. Preliminary interpretations of this subsurface data suggested something startling. The weathering profile, the zone of softened and altered rock, appeared to extend several meters down into the bedrock floor. This is not what you would expect from simple wind and sand erosion over 4,500 years. That type of weathering is primarily a surface phenomenon, sand blasting the top layers. Deep subsurface alteration is the hallmark of water percolation, a slow, persistent soaking that works its way down over immense periods. If the foundation of the house is wet far below ground level, the house has been standing through many, many rainy seasons. These hidden seismic echoes, these whispers from the deep rock, add a powerful third dimension to the argument. They suggest the water damage to the Sphinx is not a superficial skin condition, but a systemic one reaching into its very bones. This transforms the monument from a solitary, weathered statue into the tip of a much larger geological iceberg, a visible peak atop a vast, altered foundation that remembers a world of rain. The true scale of its history may be buried, waiting for us to fully understand the message resonating from the dark silence beneath the sand. The year was 1991, and a quiet revolution was about to unfold in a conference hall. The modern, scientific debate over the Sphinx's age was not born in the desert sun, but under the fluorescent lights of an academic meeting. It was here that a Boston University geologist named Robert Schoch stepped to the podium at a Geological Society of America conference. His presence alone was a signal. He was not an archaeologist or a historian, but a mainstream geologist specializing in rock weathering. He had been invited to examine the monument by writer John Anthony West, who had long questioned the orthodox timeline. Schoch brought with him no theories of lost civilizations, only the trained eye of his discipline and a simple, powerful question: what do these rocks tell us? His conclusion, presented to a room of his peers, was a seismic shock to the established narrative. Schoch argued, based purely on the geological evidence, that the deepest and most characteristic weathering patterns on the Sphinx and its enclosure walls were caused by precipitation, by prolonged and heavy rainfall. This was not a minor adjustment. To create that degree of water erosion, he stated, the core structure would have needed to be exposed to such conditions for many centuries. His geological assessment pointed to an initial construction date far earlier than anyone had seriously considered in modern times, pushing it back to at least 5,000 to 7,000 years before the Common Era, possibly even earlier. This was a pivotal moment. With Schoch's entry, the discussion was instantly transformed. It was no longer a fringe speculation or a mystery for alternative history buffs. It was now a legitimate, if intensely controversial, scientific dispute. A credentialed geologist from a respected institution was using the established language of his field to challenge the foundations of Egyptology. The core of the conflict was laid bare. On one side stood the weight of archaeological interpretation, built on context, style, and cultural analysis. On the other stood a dataset written in stone itself, interpreted through the principles of earth science. Schoch's work forced a fundamental question. When two respected disciplines look at the same object and see two vastly different histories, which do we trust? Do we prioritize the cultural story built by archaeologists or the physical story read by geologists? This was not merely an argument about dates. It was a clash of methodologies, a reminder that history is not only found in artifacts and texts, but is also encoded in the very landscape. Schoch's analysis acted like a pry bar, forcing a crack in a door that had been considered closed for a century. It challenged everyone, experts and the public alike. to look at the Sphinx not just as a cultural icon, but as a geological specimen with a story that might not fit neatly into our textbooks. The controversy he ignited continues to echo because it touches on a deeper truth about how we uncover the past, and whether we are sometimes so focused on the story we expect to find that we miss the one the evidence is actually telling. The reaction from the world of archaeology was swift and unequivocal. For every geologist pointing to the weathered stone, there stood an archaeologist pointing to the silent ground around it. Their argument is not about the erosion patterns themselves, but about the profound, echoing emptiness they believe those patterns imply. If the Sphinx truly dates to 7,000 years before the Common Era, where is everything else? Where are the quarries for such a monumental project? Where are the tool workshops, the worker settlements, the pottery, the graves, the cultural debris that always surrounds a project of this staggering scale? In the 7th millennium BC, the archaeological record for the Nile Valley shows Neolithic communities, people who were mastering agriculture and animal husbandry, creating simple but beautiful pottery. Their achievements were profound, but they were not, according to the known evidence, carving 20-story tall monuments from solid bedrock. From an archaeological perspective, the Sphinx is not an isolated statue. It is the centerpiece of a vast, coherent complex. It sits within the quarry for Khufu's pyramid. Its temple aligns with his valley temple, and the stylistic evolution of monumental sculpture in Egypt flows logically toward its form. To pluck the Sphinx from this intricate web and place it thousands of years earlier is, to many experts, to create a historical phantom. It places a technological and artistic masterpiece in a cultural vacuum, an impossibility in their view. This is the heart of the stalemate. It is a conflict between two very different ways of knowing the past. Geology reads the biography of the rock, a story of environmental change written over millennia. Archaeology reads the biography of human activity, a story of cultural development written in artifacts and settlement patterns. One sees a monument shaped by ancient rains, the other sees a monument that could only exist within a specific, later social order. The question becomes, which biography do we trust when they seem to tell conflicting stories? Are we missing a whole chapter of human civilization, or are we misreading the natural forces that shaped the stone? This standoff forces a deeper, more philosophical examination. It asks us to define what constitutes proof. Is the physical condition of the monument itself not the most primary evidence of all? Or does an object without a cultural context become an anomaly without a history, a puzzle piece that cannot belong to the puzzle we have assembled? The archaeologist's pushback is not a dismissal, it is a vital demand for coherence. They are guarding the integrity of a historical narrative built painstakingly over centuries of excavation. To accept an older Sphinx is not to change a date in a textbook. It is to confront the possibility of a lost epoch, a sophistication in the deep past that left no other trace we have yet recognized. This is the true weight of the debate, a tension between the story told by a single, silent witness and the story told by the collective whispers of an entire civilization. But the Sphinx does not stand alone in its weathered silence. Its story is echoed by the very stones that surround it. Just to the south lies the Valley Temple, a structure traditionally attributed to Pharaoh Khufu, built from colossal limestone blocks and sheathed in magnificent red granite. At first glance, it is a masterpiece of Old Kingdom engineering, fitting perfectly into the established timeline. Yet when you look closer, a curious pattern emerges. The massive core blocks of this temple, those hidden beneath the polished granite facing, show something familiar. Their surfaces bear the same deep, undulating, rounded weathering profiles seen on the Sphinx enclosure walls. It is the same signature etched into different stones. This presents a fascinating correlative enigma. If the temple was built new in Khufu's time, why would its freshly quarried blocks already carry the scars of millennia of water erosion? The most logical geological explanation is that these blocks were not freshly quarried at all. They were taken from somewhere else, from an existing source of stone that had already been exposed to the elements for a very long time. Some researchers propose that the core of the Valley Temple is built from recycled megaliths, stones that were originally part of an even older, now vanished structure that stood on the Giza Plateau. This idea transforms the site from a single mystery into a potential complex of mysteries. Imagine a later civilization arriving at Giza, finding not a blank slate, but a landscape already marked by colossal, weathered ruins. They see these immense blocks, beautifully shaped yet deeply scarred by time, lying scattered or perhaps still partly standing. Recognizing their strength and grandeur, they decide to incorporate them into their own new temples, effectively building their history upon the bones of an older one. This is not just about a statue being older, it is about the possibility of a lost architectural language. The weathering pattern becomes a kind of material fingerprint, linking the Sphinx enclosure and the temple core blocks to the same ancient climatic event. They both seem to remember the rain. This suggests a cycle far more profound than a simple construction project. It hints at a process of cultural rediscovery, where a later people encountered the legacy of a forgotten epoch and chose to weave its physical remnants into their own sacred landscape. The Sphinx, then, might not be an isolated anomaly, but the most prominent survivor of a much larger story, a story written in water-worn stone and waiting patiently for its chapters to be read in sequence. But a single glance at the Sphinx reveals another, more visual puzzle. Its head seems oddly small, perched atop that vast, lion-like body like a crown that does not quite fit. The proportions feel off, as if the monument was designed with a different balance in mind. This artistic discrepancy is more than just an aesthetic curiosity. It is a clue that points toward a dramatic historical intervention. The theory is as bold as it is simple. Perhaps the original Sphinx did not have the face of a pharaoh at all. Perhaps it began its existence as a true lion, a monolithic beast with a head scaled perfectly to its powerful torso. The severe, deeply channeled erosion that ravages the body stands in stark contrast to the head, which, while damaged, retains a far more defined and crisp structural form. If the entire monument had been exposed to the same punishing elements for the same 4,500-year period, why would the weathering be so dramatically different between the neck and the paws? One compelling explanation is that they were not exposed together for that entire time. The head we see today, according to this view, is not the original. It is a recarving. Imagine a much older, weathered lion statue, its original head softened and worn down by millennia of rain and wind. Then, centuries or even millennia later, a new civilization arrives. They find this colossal, enigmatic guardian, a symbol of immense power and antiquity, but its face is blurred by time. To claim its power, to connect their own reign to this ancient magic, they reshape that worn stone. They carefully carve away the old, eroded form and sculpt a new visage, the face of their own king, Pharaoh Khafre. This act would not be mere vanity, it would be a profound statement of symbolic appropriation. It is the architectural equivalent of a new ruler stamping his seal on an old, venerated treaty, asserting continuity and dominion over a legacy he did not create but desperately wished to inherit. The geological evidence of the body whispers of great age, while the proportional mismatch of the head hints at a later chapter, a dynastic update to a primordial icon. This would explain why the head shows less of the deep water erosion. Its surface stone is newer, having been exposed to the elements for a far shorter period, only since the time of its recarving. The Sphinx then becomes a palimpsest in stone, a monument with two distinct creation stories layered one upon the other. Its body holds the memory of a forgotten epoch, while its face gazes out from the age of pyramids, a bridge between two worlds that history has forgotten were connected. The pyramids themselves offer a silent but powerful comparison. If you walk the Giza plateau and run your hand over the limestone casing stones still clinging to the base of Khufu's pyramid, or examine the exposed core blocks of the Great Pyramid, you feel a specific texture. The surfaces are pitted, granular, worn smooth in a flat, even way. This is the signature of the desert wind, carrying abrasive sand particles that have scoured these surfaces for 4,500 years. It is a horizontal, sandblasted finish. Now, turn and look at the Sphinx enclosure walls just a short distance away. The stone there is not merely pitted, it is deeply channeled, with rounded, undulating hollows that look sculpted by flowing liquid. These two monuments, supposedly contemporaries built within decades of each other from the same local limestone, display fundamentally different biographies written in stone. The difference is not subtle, it is categorical. They appear to have aged under two completely different skies. This comparative geology acts as a crucial control for our historical experiment. When scientists want to test a hypothesis, they look for a control group, a set of conditions that are identical except for the one variable being tested. Here, the other Old Kingdom structures are that control group. They are built from the same geological material. They have sat in the same desert climate for the same amount of time according to the traditional timeline. Their weathering pattern tells us what 4.5 millennia of Giza's arid environment does to this specific limestone. It creates wind-worn faces. The Sphinx, however, tells a different story entirely. Its erosion profile is not just more severe, it is of a different kind altogether. This makes it a profound outlier. Even structures from the 3rd dynasty, slightly older than Khufu's 4th dynasty, such as the step pyramid complex at Saqqara, do not exhibit this type of deep, vertical channeling. Their damage aligns with the expected effects of time in a dry environment, so the question becomes unavoidable. Why would one member of this architectural family bear such unique and dramatic scars? If all these monuments shared the same history, they should share the same aging process. The fact that they do not suggests the Sphinx has a hidden chapter in its past, a period of exposure that the others never experienced. It stood witness to an element the pyramids never knew, an element that stopped shaping the landscape long before the first pyramid block was ever cut. This side-by-side evidence transforms the Sphinx from a mystery into a geological anomaly, a relic that seems to remember a world its younger neighbors never saw. The stones tell a story of water, but the sky above them holds a different kind of record, one written in the slow, grand turn of the stars. This leads us to a theory that steps beyond geology and into the realm of celestial memory, a concept known as the Orion correlation theory. Proposed by researchers like Robert Bovell, this idea suggests the monuments of Giza are not randomly placed, but are part of a deliberate skyward map. The theory posits that the layout of the 3 Great Pyramids mirrors the precise arrangement of the 3 stars in Orion's belt, but not as they appear today. Instead, Bovell and others argue the ground plan matches the celestial pattern as it would have been observed in the night sky around 10,500 years before the Common Era. This date, derived from astronomical software that can rewind the stars, is not a random guess. It is pinpointed to a moment when Orion reached its lowest point in its 26,000-year precessional cycle, a moment of profound symbolic renewal or first time in some ancient cosmologies. If this correlation is intentional, it transforms the entire plateau from a collection of tombs into a frozen moment of cosmic time, an architectural snapshot of the heavens from an epoch lost to history. The implications for the Sphinx within this celestial blueprint are staggering. Proponents of this view note that the Sphinx, a lion-bodied guardian, faces directly east. If we roll back the celestial clock to that same remote era of 10,500 BCE, we find that at the spring equinox, the constellation Leo would have been rising directly in the eastern dawn sky ahead of the sun. In this model, the Sphinx is not merely facing the sunrise, it is gazing directly at its own celestial counterpart, the lion in the stars, on the first day of spring in a forgotten age. This alignment offers something the geological evidence alone cannot, a potential motive. Why would anyone carve a monument of such impossible scale in a pre-agricultural era? The archaeoastronomical hypothesis provides an answer, a reason rooted in deep cosmic observation. The construction could have been an act of sacred mirroring, a desperate attempt to anchor a fleeting celestial event into the permanent bedrock of the Earth, to synchronize human ritual with the grandest clock of all, the precession of the equinoxes. This theory, while captivating, exists at the very edge of mainstream archaeology and is met with intense skepticism. Critics argue that the correlation between the pyramids and Orion's belt is not precise enough to be conclusive, and that the ancient Egyptians of the Old Kingdom left no textual records suggesting such a sophisticated, long-term astronomical understanding tied to that specific date. They see it as a case of modern pattern seeking projected onto the past, connecting dots that the original builders never intended to connect. Yet, even as a controversial hypothesis, it completes a compelling, if unproven, narrative triangle. The geology suggests the Sphinx endured ancient rains, the seismic whispers hint at deep weathering, and now the stars propose a possible when and why, a celestial context for that weathered sentinel. Together, they weave a story of a monument that is not just old but purposefully ancient, designed to commemorate a moment when the sky itself looked profoundly different. Whether one accepts the celestial map or not, it challenges us to expand our imagination of what the deep past might have been capable of perceiving, and what messages they might have tried to send across the millennia, not in words but in stone and alignment. Who could have possibly carved such a monument when the world was still young? If the geological whispers are correct, and the Sphinx truly remembers rains that fell over 7,000 years before the Common Era, we are staring at a profound historical void. This is not a gap of a few centuries but a chasm of millennia. This proposed date places the Sphinx's creation in a time before the pharaohs, before the unification of Egypt, even before the widespread adoption of farming along the Nile. The world then was one of small, mobile communities of hunter-gatherers and early pastoralists, people whose legacy we find in stone tools and rock art, not in 20-story-tall monoliths. The sheer scale and precision of the Sphinx, its conception as a single, unified sculpture hewn from bedrock, seems to belong to a different order of society entirely. This disconnect between the artifact and the known archaeological record for that era is the core of the mystery. It is like finding a smartphone in a medieval castle, a technological and conceptual outlier that simply does not fit the established timeline. So who or what does that leave as the possible creator? The geological evidence, for all its clarity about water and time, is utterly silent on this point. It tells us the stone is old, but it cannot tell us who held the chisels. This silence has inevitably been filled with speculation, ranging from the intriguing to the extraordinary. Some researchers point to the sophisticated megalithic sites like Göbekli Tepe in Turkey, which dates to a similar remote epoch. That site, with its massive, intricately carved T-shaped pillars arranged in circles, proves that Neolithic peoples were capable of staggering communal projects and complex symbolic thought long before cities or empires. Could a culture of similar ambition and skill have existed in the Nile Valley, leaving the Sphinx as its sole, defiant survivor? Others look further, to the realm of myth and collective memory. Nearly every ancient culture speaks of a golden age, a time before a great flood when wise beings or gods walked the earth and imparted knowledge. The Egyptian texts themselves speak of Tepe, the first time, a primordial epoch of creation when the gods ruled on Earth. Could the Sphinx be a physical memory of that mythical age, a monument so ancient that by the time of the pharaohs, its true origins were already lost to legend, leaving them to claim it as their own? This line of thinking leads to the controversial idea of a lost civilization, an advanced culture that flourished and then vanished, perhaps in the climatic upheavals at the end of the last ice age, leaving only scattered monumental clues. It is a captivating narrative, one that speaks to a deep human fascination with forgotten worlds and fallen giants. Yet it is crucial to separate the solid geological data from the speculative historical conclusions. The rocks tell us the Sphinx is weathered by ancient rain. They do not tell us the builders had flying machines or cosmic wisdom. What the evidence genuinely expands is not a roster of ancient technologies, but the canvas of human possibility. It suggests that the story of civilization, of complex social organization and monumental achievement may not be a linear, upward march from simple to complex. Instead, it might be a story of cycles of cultures rising to great heights, leaving their mark on the landscape, and then receding back into the sands of time, their stories erased by climate change, migration, or catastrophe. The Sphinx, in this view, becomes a humbling lesson in deep time. It stands as a potential testament to a cycle of cultural rise and collapse so deep that our written records, which feel so comprehensive, recall only the most recent chapters. Our entire recorded history from the first pharaoh to the present day spans a mere 5,000 years. The Sphinx, if its older date is accepted, asks us to consider that another 5,000 years of human drama, ambition, and artistry might lie unrecorded before that. This does not necessarily require a hyper-advanced lost world, but it does demand a radical openness to the depths of human ingenuity in epochs we have barely begun to understand. It challenges the very notion of progress, reminding us that greatness is not the exclusive property of the modern world or the classical ages, but a flame that can burn brightly, be forgotten, and be lit again in the long, dark night of prehistory. The debate over the Sphinx age is often framed as a simple clash between two camps, yet within the world of geology itself, there exists a rich and varied spectrum of opinion. It is a misconception to believe that all mainstream scientists dismiss the idea of an older monument outright. The reality is far more interesting, reflecting the careful, sometimes cautious, nature of scientific inquiry. Many geologists who have studied the site agree on a foundational point. The distinctive weathering on the Sphinx enclosure is not typical of a dry, sandy environment. The patterns do suggest the action of water. Where opinions diverge is on the scale, duration, and timing of that water event. Some researchers propose a compromise scenario. They acknowledge the water erosion but suggest it could be the result of a shorter, wetter climatic phase within the early Old Kingdom itself, or perhaps from catastrophic but occasional Nile floods that pooled in the enclosure. This view attempts to reconcile the geological data with the traditional archaeological timeline, suggesting the necessary rains did not need to vanish millennia earlier. They just needed to be more frequent for a few centuries during the Pyramid Age. Other geologists, while impressed by the evidence for prolonged precipitation, remain openly agnostic on pinning down an exact date. They see the data as clear on the how but ambiguous on the when. Establishing a precise chronology from erosion patterns alone is notoriously difficult, like trying to determine exactly how long a wooden bench sat in the rain by looking at the depth of its grooves. You know it was exposed to storms, but was it for 50 years or 500? The rock records the event, but not a calendar date. This professional caution is not a dismissal, it is a hallmark of rigorous science. It underscores that the geological community is actively engaged with the puzzle, not ignoring it. This internal debate is not a sign of weakness in the older Sphinx theory, but rather a sign of healthy, evolving science. Competing interpretations are tested, models are refined, and the conversation deepens. The most significant outcome of this geological scrutiny is a firmly established fact that archaeology can no longer overlook. The weathering of the Sphinx is complex, severe, and environmentally specific. It is a physical dataset that demands an explanation. Whether one believes the cause was 1,000 years of rain or 100 years of exceptional floods, the stone itself tells us that the environmental history of that site is more complicated than we once assumed. This forces a more nuanced, interdisciplinary dialogue. It moves the discussion from a defensive argument over who is right to a collaborative investigation of what the evidence means. The stones have spoken, and their language, while open to some interpretation, has undeniably changed the question. We are no longer asking if the Sphinx story is simple, but how we can read its complex biography in full. The water that shaped the Sphinx may not have fallen from the sky. A compelling counterpoint to the ancient rainfall theory suggests the source was much closer to home, rising from the earth itself or rushing in from the great river. This alternative view does not deny the water erosion. It simply proposes a different delivery system, one that could potentially fit within the traditional timeline. Imagine the water table beneath Giza not as it is today, deep and distant, but as a high, persistent aquifer, its moisture constantly seeping upward into the limestone. Or picture the Nile River in a more volatile era, its annual floods not just watering fields but occasionally surging with catastrophic force, spilling over its banks and pouring into the Sphinx enclosure, filling it like a giant bathtub. In this scenario, the monument could have been repeatedly saturated from below or submerged from the side, its stone slowly dissolving and flaking away through capillary action and chemical weathering, all within the last 5,000 years. This hydraulic debate is not about whether water was present, but about its behavior and its power to sculpt. Could the gentle, persistent soak of a high water table, or the violent, intermittent inundation of epic floods, create those same deep, vertical channels that so strongly suggest rainfall? Critics of this idea point to the physics of the erosion. Floodwater, by its nature, seeks a level. It pools, it sits. The damage it causes is often horizontal, undermining foundations and leaving waterlines, not carving precise vertical runnels down a wall. The weathering on the Sphinx enclosure is distinctly vertical and channelized, following the downward path of water flowing under the influence of gravity, not sitting in stillness. It is the difference between the even wear on a stone at the bottom of a pond and the grooved, dramatic face of a cliffside waterfall. For a high water table to be the primary agent, the moisture would need to wick upward through the stone and then somehow evaporate or flow in a way that consistently created vertical patterns, a process many geologists find difficult to model. This debate shifts our focus from climate to hydrology, from ancient weather to the forgotten behavior of the land itself. It asks us to consider every possible source for the water that left its mark, testing each hypothesis against the specific, unforgiving grammar of the stone's wounds. Whether the water fell, rose, or flooded in, its lasting signature challenges us to map the lost hydrology of the plateau, to see the Sphinx not just as a statue, but as a stone gauge that measured the forgotten ebb and flow of the world beneath our feet. The debate over water sources and timelines brings us to a crucial modern turning point. For centuries, we have relied on the human eye and educated deduction to read the Sphinx story. But today, we are no longer limited to looking at the stone. We can listen to it with a new kind of precision. The key lies in technologies like LiDAR, which stands for light detection and ranging, and advanced photogrammetric three-dimensional modeling. Think of these tools as giving the monument a complete digital twin, a perfect, measurable copy that exists inside a computer. A LiDAR scanner works by firing millions of laser pulses at the surface, each one bouncing back to create a point of data. When you combine all these points, you build an incredibly detailed three-dimensional map of every contour, every crack, every subtle undulation on the statue and its enclosure walls. This is not a photograph, it is a topographic record of its current state, accurate down to the millimeter. This digital frontier fundamentally changes the nature of the investigation. For the first time, we can move the discussion from qualitative observation, which can be subjective, to hard, quantitative analysis. Instead of saying the erosion looks like it was caused by water, scientists can now measure it. They can calculate the exact depth and volume of the channels, map their directional flow patterns across the entire surface, and compare these digital signatures to other known examples of water-worn limestone from around the world. But the real power goes beyond simple measurement. With a perfect three-dimensional model, researchers can run virtual experiments. They can program the software to simulate different climatic scenarios over vast stretches of time. Imagine telling the computer to subject the digital Sphinx to 1,000 years of moderate wind and sand, then to 1,000 years of heavy seasonal rainfall, and then to a mix of both. The software can model how each scenario would interact with the specific, layered composition of the Giza limestone, predicting where erosion would concentrate, how deep it would cut, and what final shape it would leave behind. This allows for a kind of forensic testing that was previously impossible. By running these simulations and comparing the virtual results to the actual, scanned erosion patterns, scientists can begin to rule certain theories in or out with greater confidence. Could the observed damage be replicated by wind and sporadic floods over 4,500 years? Or does the digital stone only match the simulated output of a much longer, wetter period? These tools do not provide an instant answer, but they create a rigorous, testable framework for the debate. They transform the Sphinx from a static mystery into a dynamic laboratory. Every groove becomes a data point, every hollow a piece of evidence in a computational experiment spanning millennia. This is where the mystery may eventually find its resolution, not in a dramatic new discovery, but in the quiet hum of a server, running countless years of virtual weather against the silent, waiting stone. Beyond the stones and stars, there is a human story woven into this debate. Why does the suggestion of an older Sphinx encounter such profound resistance? The answer lies not in the bedrock, but in the very foundations of how we understand ourselves. The Great Sphinx is more than an archaeological site. It is a pillar of cultural identity, a symbol etched into the heart of a nation's history and its global image. To challenge its age is to touch something deeply personal and professionally monumental. The field of Egyptology is built upon decades of meticulous scholarship, a grand narrative carefully constructed from fragments of pottery, tomb inscriptions, and architectural styles. This narrative is not just in books, it is in museum displays, documentary films, and the stories told to millions of visitors each year. It forms the backbone of a national heritage that fuels both pride and tourism. Proposing a radical redating is not merely an academic adjustment, it is an earthquake. It would demand a rewriting of textbooks, a reinterpretation of dynastic timelines, and a rethinking of what we believe about the dawn of monumental civilization itself. For scholars who have dedicated their lives to this established framework, such a shift can feel like an undermining of their life's work, a challenge to a hard-won consensus. This is the sociology of knowledge in action, a reminder that our interpretation of the past is never a purely objective exercise. It is always filtered through the priorities, perspectives, and institutional structures of the present. A new idea must do more than present evidence. It must navigate a labyrinth of professional reputation, funding avenues, and deeply held beliefs. The resistance, then, is understandable. It is a protective instinct, a safeguarding of a coherent story against a disruptive, if compelling, outlier. This human dimension adds a crucial layer to the mystery. It means that solving the riddle of the Sphinx requires more than geological analysis. It requires a willingness to engage in a difficult, respectful conversation across disciplinary lines. It asks us to hold two truths at once, to honor the immense achievement of established archaeology while remaining open to the quiet, persistent testimony of the stone itself. The true age of the Guardian may ultimately be found not in a single discipline's victory, but in the uneasy, fertile space where geology meets history and where our certainties are asked to make room for a deeper, more complex story. Göbekli Tepe stands on a wind-scoured hill in Turkey, a silent revolution in stone. This vast complex of circular enclosures, its T-shaped pillars intricately carved with foxes, boars, and birds, was deliberately buried and forgotten around 9,600 years before the Common Era. Its discovery sent shockwaves through archaeology, not because it revealed a lost city or a written language, but because it fundamentally rewrote the story of human ambition. Here, in a time we previously pictured as one of simple hunter-gatherers, people came together to execute a project of staggering scale and sophistication. They quarried, transported, and erected multi-ton limestone pillars, arranging them with clear geometric and symbolic intent. This was not a practical settlement, it was a ceremonial center, a testament to a shared belief system powerful enough to mobilize a pre-agricultural society. Göbekli Tepe does not tell us who built the Sphinx, but it changes the entire landscape of what we thought was possible in the deep past. For decades, a primary argument against an older Sphinx was a simple one: who could have done it? The archaeological record for Egypt around 7000 BC showed no evidence of a society with the organizational capacity or the technical skill for such a monolithic undertaking. Göbekli Tepe shattered that assumption of impossibility. It proved that the human drive to create monumental, symbolic architecture is not a product of agriculture, cities, or kingship. It can spring from something older, from a communal spiritual vision that we are only beginning to understand. The two sites are not directly comparable, of course. Göbekli Tepe is an assembly of many carved pillars, while the Sphinx is a single, colossal sculpture hewn from living bedrock. Their styles, their cultural contexts are worlds apart. But the parallel is not in their form, it is in their foundational message. Both represent a leap in scale, a mastery of stone, and a commitment to a vision that would outlast generations. This is the crucial shift in context. Before Göbekli Tepe, the idea of a 9,000-year-old Sphinx seemed to demand an entirely unknown, advanced civilization, a phantom in the historical record. Now we have a tangible, excavated precedent. We know that human communities, even without metal tools or the wheel, were capable of conceiving and completing awe-inspiring megalithic projects in that very same remote epoch. The goalposts of human potential have been moved back by thousands of years. This does not make the older Sphinx a proven fact, but it transforms the hypothesis from an archaeological outlier into a plausible scenario that must be taken seriously. It asks a new, more nuanced question. If the people of Anatolia could create Göbekli Tepe, what might the people of the Nile Valley, with its different resources and beliefs, have been capable of at the same time? The silence of the Egyptian archaeological record for that period is no longer proof of inability. It is simply a silence, a gap waiting to be filled by future discoveries or a new interpretation of old evidence. Göbekli Tepe reminds us that history is not a linear march from simple to complex. It is a story of flashes of brilliance, of cultures that gather their collective will to touch the eternal, only to fade away, leaving their greatest works as riddles for the future. The Sphinx gazing east may be another such flash, a solitary echo from a time when humanity first dared to carve its questions into the bones of the earth. This idea of a layered history transforms the Sphinx from a statue into a storybook. A palimpsest is an ancient manuscript, a parchment or tablet where the original writing was scraped or washed away so the valuable material could be reused for a new text. Over centuries, the old ink, never fully erased, can seep back to the surface, creating a ghostly overlap of messages from different times. This is precisely what the Sphinx appears to be, not a single page from history, but a volume that has been edited, annotated, and reinterpreted across epochs. The original bedrock sculpture, whether a lion or some other form, is that first foundational text carved into the living stone of the plateau. The deep water erosion is not damage in this metaphor, but a powerful environmental stain, a seepage of climate history that saturated the parchment and left its indelible mark. If the recarving of the head occurred, that act is the new inscription written over the faded original, a conscious decision by a later culture to claim the narrative. And every intervention since, from the restorative efforts of Pharaoh Thutmose IV, who famously dreamed the Sphinx promised him a kingdom, to Roman-era repairs, to the modern cement and stone patches that hold it together today, these are all marginal notes, footnotes added by successive generations trying to preserve, or perhaps control, the meaning of this enduring text. Geology, then, becomes our method for reading the oldest, most faded script. It is the scholarly discipline that allows us to see past the clearer, more recent handwriting to discern the ghostly impressions of the first message. This perspective is liberating. It releases us from the exhausting debate over a single, correct date and invites us to appreciate the monument's true nature as an accumulator of time. The Sphinx did not spring complete from the mind of one pharaoh. It is a collaborative work between cultures that may never have known each other, a sculpture that has been reshaped not just by human hands, but by the very climate of the planet. Its body holds a memory of rain, its face may hold the visage of a king, and its pores are cradled by the masonry of empires that rose and fell millennia later. To stand before it is to stand before a physical timeline, a monument that has silently witnessed the procession of ages, each leaving its own subtle signature upon the stone. This layered reality does not simplify the mystery, it deepens it, asking us to listen not for one story, but for a chorus of whispers from across the abyss of time. The guardians of the Sphinx today face a profound and necessary dilemma. Every potential answer to its age seems to require a question we are no longer permitted to ask in the way we might wish. The monument is not just an artifact, it is a fragile, priceless World Heritage Site, a symbol for all of humanity. This status brings with it an ironclad responsibility, preservation above all else. Imagine proposing to take core samples from its weathered flanks, or to conduct extensive, invasive subsurface surveys around its base. The very idea is met with understandable and immediate caution. The techniques that could provide definitive mineralogical data or clearer subsurface profiles are often the same techniques that risk causing irreversible damage to the stone. This creates a modern version of an ancient riddle, a catch-22. To prove the Sphinx is older, we might need evidence that we are ethically barred from collecting. The most compelling clues may lie locked within the monument itself, in places we have sworn to protect from any further disturbance. This tension is not a failure of science or of stewardship, but a reflection of our evolving values. We have moved from an era of excavation, where discovery sometimes came at a cost to the site, into an era of conservation, where the integrity of the legacy for future generations is paramount. The debate over the Sphinx's age is thus uniquely preserved, frozen not by a lack of curiosity, but by a surplus of care. It ensures that the mystery will continue to live in the realm of interpretation, of piecing together clues from non-invasive scans, from photographic analysis, and from the re-examination of old data with new eyes. The monument's greatest protection against a final, definitive answer may be our own collective decision to shield it from the very tools that could provide one. This leaves us in a fascinating space, a frontier of knowledge defined by its limits. We are asked to solve a monumental puzzle with our hands respectfully tied behind our backs, forced to rely on observation, deduction, and technological ingenuity that does not touch the stone. It is a testament to the enduring power of the question itself, that it can captivate us so completely even when the path to a simple answer is ethically closed. The Sphinx, in its silent wisdom, may have achieved the ultimate state for such an ancient sentinel. It has made its own preservation more important than our understanding, ensuring that its secret, if it holds one, will be kept safe within the very rock we are pledged to protect. The debate, therefore, is not a problem to be solved, but a conversation to be sustained, a perpetual reminder that some mysteries are meant to be pondered, not merely dissected. The evidence presents us not with a single story, but with a tapestry of possibilities, each thread pulled from a different discipline. On one hand, the stone speaks a clear language of water, of a climate that faded from memory over 5,000 years ago. On the other, the artifacts and architecture of the plateau whisper of a pharaoh's ambition just 2,500 years before our common era. Reconciling these two testimonies is the heart of the mystery, and it leads us to three distinct paths, each a timeline of possibility with its own compelling logic and its own unanswered questions. The first path is the most dramatic, the one where geology takes the lead. Here, the Sphinx is a relic of a much older world, its form carved from the bedrock during or before the last great rainy epoch of the Neolithic subpluvial. In this scenario, the monument stood fully exposed for millennia, its flanks slowly sculpted by the persistent rains of a green Sahara. By the time the first dynasties of Egypt emerged, the Sphinx was already an ancient, weathered guardian, a natural monument to a forgotten age. The later civilization of the Old Kingdom, finding this colossal lion on their doorstep, would have seen it as a divine sign, a primordial power to be claimed and incorporated. They might have cleared the sand from its base, recarved its weathered head into the face of their king, and built their temples around it, weaving their new kingdom into the fabric of a deep, sacred past. The merit of this timeline is its elegant fit with the most severe erosion data. The flaw is the profound silence it requires from the archaeological record, asking us to accept a civilization capable of such work, leaving behind no other traces we have yet recognized. The second path seeks a middle ground, keeping the Sphinx within the age of pyramids but explaining its unique scars. This theory accepts the water erosion but proposes a different source, a unique local hydrology that accelerated the process within the traditional time frame. Perhaps the water table beneath Giza was once exceptionally high, with capillary action and rising groundwater constantly saturating the lower parts of the monument. Or maybe catastrophic, once-in-a-century Nile floods breached the plateau, filling the enclosure and soaking the limestone repeatedly. This could have created concentrated weathering over centuries rather than millennia. The merit here is that it respects the established archaeological context. The flaw lies in the physics. Many geologists argue that standing floodwater or rising damp creates horizontal weathering lines and subsurface dissolution, not the pronounced vertical channels we see carved so decisively into the enclosure walls. The third path offers a different kind of synthesis, one that blurs the line between natural wonder and human artistry. Imagine the Giza Plateau 10,000 years ago. Wind and rain work on a natural outcrop of limestone, a protrusion that already vaguely resembles a crouching animal. Over ages, these elements carved the deep, undulating hollows and runnels. Later, humans arrive. They see in this wind and water-shaped formation a powerful symbol, a lion emerging from the earth itself. With a profound sense of reverence, they do not carve a statue from scratch, but instead enhance what nature has provided. They define the pores, deepen the outline of the body, and sculpt a face upon the natural rock head. This scenario makes the Sphinx a collaborative work between planet and people. Its great age comes from the natural erosion phase, while its recognizable form is the later, perhaps Old Kingdom, human touch. The merit is its creative compromise. The flaw is that it requires a remarkably fortuitous natural formation, one that just happened to align with a culturally significant symbol in the exact right location. So where does this leave us? Not with a solved equation, but with a richer, more nuanced picture of deep history. These are not competing truths waiting for one to be declared victor. They are different lenses through which we can view the same enigmatic monument. Perhaps the most honest conclusion we can draw is that the Sphinx defies a simple timeline because it is not a simple object. It is a chronicle written in stone, water, and human aspiration. Its true story may be a composite of all these possibilities, a narrative of natural shaping, ancient carving, later appropriation, and continuous reverence. The puzzle endures not because the evidence is weak, but because it is so profoundly deep, inviting us to keep looking, keep questioning, and remain humble before a mystery that has guarded its secrets for longer than civilization has kept its records. Perhaps the most compelling aspect of this debate is not the evidence itself, but the profound human need it reveals. We are drawn to the idea of an older Sphinx not merely as a scientific puzzle, but as a mirror held up to our own forgotten past. This weathered guardian represents a gap in the story of us, a silent question mark carved into the bedrock of history. It whispers of epochs unrecorded, of chapters in the human saga that were lost before the first clay tablet was ever inscribed. In its patient, eroded gaze, we see the reflection of our own deepest curiosity, a longing to know what came before the beginning we think we know. This monument challenges a certain comfortable arrogance, the notion that our 5,000 years of written chronicle is the totality of meaningful human endeavor. The Sphinx, if it truly remembers ancient reigns, suggests our civilization is not the first act, but perhaps a later scene in a much longer, more cyclical drama. This possibility is electrifying. It re-enchants the world, suggesting that the ground beneath our feet might hold memories far older than our oldest stories. This is why the debate endures with such vitality, fueling endless documentaries, books, and late-night conversations. It taps into a universal fascination with lost origins and buried wisdom, the romantic idea that giants once walked the earth and left behind clues for us to decipher. The mystery is powerful precisely because it resists a final answer. A solved riddle becomes a fact filed away. An enduring mystery, however, remains a living question, a catalyst for imagination and inquiry. It forces us to remain humble, to acknowledge the limits of our knowledge, and to keep looking at the familiar world with wondering eyes. The Sphinx, therefore, is more than a statue. It is a perpetual provocation, a stone sentinel whose primary function may not be to guard a pharaoh's tomb, but to guard the very idea of mystery itself, ensuring we never become so certain of our past that we stop dreaming of its hidden depths. The stones have spoken, and their story cannot be easily dismissed. The geological evidence for an older Sphinx presents a formidable challenge, a quiet but persistent argument written in the undeniable language of water-scarred limestone. It asks us to weigh the physical biography of the rock against the cultural narrative built around it. While this evidence may not be conclusive in a court of history, it is compelling enough to reshape the conversation entirely. It forces a simple, profound shift in perspective, compelling us to remain genuinely open to the possibility that the canvas of human achievement extends much further back into the deep past than our textbooks have traditionally allowed. We are invited to consider that the story of civilization may not be a straight line, but a series of cycles, with brilliant flashes of communal effort that flickered and faded long before the age of pharaohs. The Sphinx, in its silent vigil, embodies this revised understanding. It stands as a permanent reminder that the past is not a fixed story, sealed and complete, but a living narrative constantly being revised, word by word, by each new piece of evidence we uncover. It teaches a vital lesson in intellectual humility, showing that our knowledge of history is always provisional, always awaiting the next discovery that might tilt the entire picture. Whether this great guardian ultimately holds the secrets of a forgotten human epoch, or simply bears witness to the immense, sculpting power of natural forces over time, its true age may forever remain its most captivating enigma. That enduring mystery is perhaps its greatest gift to us, a perpetual invitation to wonder, to question, and to look deeper. I encourage you to take that curiosity further. Delve into the research from both sides of this debate. Listen to the geologists and the archaeologists, and see where the evidence leads your own understanding. Share your thoughts and conclusions in the comments below, as this is a conversation that thrives on diverse perspectives. If you enjoyed this journey to the very edge of known history, consider subscribing for more explorations into the world's greatest enduring mysteries.